Hey, here's another quick video on a Uniden AX144, which I repaired and did a channel expansion on. This one comes fitted with a masked PLL, so I replaced the PLL chip with another PLL chip which doesn't have any limitations, a serial PLL chip. And I put back in here an LED block. I like the LED readout on radio, so I kept this as an LED. It's got a little module in there which lets you address 7-segment displays with an I2C bus, so I'll show you that in a minute as well. I kept the original channel dial as well, the channel switch in the back, and I just tap off some of the pins on that switch. That goes into the Nano, and then I just detect which direction that's going. I kind of use the original channel dial really as a rotary encoder. So instead of putting a rotary encoder in there, just tap off the channel dial. It's also got, so it's a 40 channel dial, but it's got dial acceleration on it. So if you turn it at a normal rate, it will just go through the 40 odd channels. But if you turn it a little bit faster, you see you can probably get about 80 or 90 channels in sort of 3/4 of a turn. And then when you get near the channel you want, you kind of just slow down. So that works quite well. So yeah, there's a 5kc drop here, and that's a bright dim still works. I put an LED behind here, and the micro actually controls the brightness of this, because that chip, the I2C chip, you can actually send the brightness in as an instruction as well. So you can actually turn the brightness up and down with the micro. Yeah, that's about it. I'll show you inside. It's all pretty much standard. All the circuitry pretty much standard, except really the channel selection and the dial, and the channel display is pretty much the only things that I've changed, plus the VCO a little bit. This is an HT16K33. I can't remember what it is. That's the chip anyway that drives the LED from an I2C bus. The original channel dial in there, an Arduino Nano in there, and then there's a serial PLL chip here. All right, I'll show you what I did on the circuit. Okay, so this is the circuit for the AX144. There's your masked PLL chip here, which is driven from the channel selector. So I got rid of that. I'm still using this 10.24 oscillator here, which has got the upper and lower sideband shifts. I'm still using that as a reference for the new PLL. But what the new PLL doesn't have and doesn't need is this divide by 2 output, which is then picked off the third harmonic to be 15 megahertz. The 16 megahertz VCO mixes with the 15, gets filtered here and picks off the 1 megahertz signal or thereabouts, which then normally gets controlled by the PLL, and then that DC control line comes back and changes or locks the frequency of the VCO at 16 megahertz with that 1 megahertz signal. So what I do when you replace that, the new PLL will easily manage up to 60 megahertz or so. So I just changed this circuit here. This is the 16 meg. This goes out to the radio here, but it also comes back this way to be monitored by the PLL chip. So I obviously got rid of this circuit. I've got 16 meg coming back in here, and then I just changed a couple of values here and got rid of this low pass filter, and basically I bring the 16 meg straight back into the PLL chip, and then I control that 16 meg directly with the PLL chip. And as I said, I still use this as an offset for the sideband, and for the clarifier as well. It still changes the reference frequency for the PLL, which obviously in turn ends up changing the local 16 meg oscillator. All right, that's it. See you later.